Sir, in which platform exam will be conducted?
I think all of you know, but still I again like to tell you, C and D sections, it will be taken by me, and other sections will be taken by other faculty members, right? And question is same.
Sir, MCQ based.
Yes, same for all.
And sir, for maths examination, the date.
Date
So what is the
uh,
pattern of the examination? How many questions are there?
near about 9 questions are there. Marks is 15, right? And questions are MCQ. There is no negative marking. And time
Sir, how much?
is,
Sir, is numerical type means we have to fill the answer or it will be optional. 1, 2, 3, 4. A, B, C, D. We have to choose any one.
yeah, MCQ. You have to choose any one. One option is correct.
Sir, the date of exam.
How many times?
The date of exam is 11/1/22. Okay. Time is 9 to 9:30.
Sir, there is no link activated for section B, sir. In Moodle.
Oh, it will be done. It will be done by today or maybe tomorrow. Okay.
Okay.
Okay. So
Only
I
mathematics, the all subject.
no. Let me clear the things. Okay. First one is question will be MCQ type and date of examination 11/1/22. Time is 9 to 9:30. It is for all sections, right? Questions will be same, but where it will be conducted, it depends on the corresponding faculty members. For my case, it will be conducted on Moodle, and that is for only C and D sections. I gave you the key for that. So whatever the key, all of you know, CD 1, 2, 3. So that is the key for enrollment of your Mathematics 1 course. And how to find it? I think all some students, most of the students already enrolled. So if you have any problems like that, you are requested to just contact with other students, right?
Sir,
And
sir.
please let me
I came 2 minutes late. Sir, can you summarize what you said a little bit?
why you came late. I will not summarize it. This is second time I am telling.
Sir, is there any other exam on 11? Hello, sir. Am I audible?
Yes, tell.
Sir, is there any other exam on 11?
So that I do not know. I can tell only the exam for mathematics, and it is conducted in during the class time of mathematics 1. So there will be no class, right? Because the schedule is given from 9 to 9:30. It is inside the first schedule, first class of mathematics 1. So there will be no problem of classing it, right?
Yes,
sir. Hello, sir.
Will you
Sir,
send
then
the
rest of the
assignment?
class will
So
be
that
held.
we will
Sir,
get
what
the
about
idea of
the
the
8th
question.
section?
The rest of the class will be held on time.
Yes, same time.
Sir,
Excuse me,
what
sir.
is the syllabus, sir? Sir, should we
Syllabus.
have to show us
sir.
rough
Sir.
copy?
Is this
Sir,
class
will you
of
give us some
22 during
assignments so
this
that we will
examination?
get the idea of questions?
During continuous assessment?
So
CM?
what about exam for 8th section?
I have already told it.
Sir,
Sir,
what
will
is
you
the
upload
syllabus?
So please listen to me. You will get the answer of all questions.
Excuse
For
me,
this
sir.
time, I don't allow mic. Again, I tell that questions will be of MCQ type, and there is no negative marking. 9 questions will be there. It is of 15 marks. Date is 11th January. Time is 9 to 9:30 a.m. and questions, particularly the medium, basically for some sections it will be on Moodle, maybe some other sections it may be on MS Teams. So it depends on the respective faculty members. I think yesterday Dr. Bagchi has given you the guideline where which sections will be given, which sections it will be taken by which teacher, right? So for C and D, I will be taking. So this is the information. I think it is sufficient for all of you. And regarding some students are saying some assignment and questions are there. So how you can, okay, I have already given the lecture note and also whatever the questions I have solved in the class, that writing also it is given, it is posted. So, but for sample question, I can tell you one thing, maybe one question I write here, one sample questions so that you can have a feeling. Suppose I write that f is a function from your D to R and D is a subset of R2. Then integral of D f dx dy will always exist. True or false? Ion,
Yes, sir. Yes, sir.
okay, I think you heard the question.
Sir, can you tell the question again, sir? Uh, my it's gone. So
Again,
can
I
you-
am repeating the question. You can see the screen, right? Let
Yes, yes.
f be a non-negative function which is defined on some region in R2. Then double integration of f dx dy will always exist. This is true or false? Rishi,
Sir, false. Sir, because iterative integrals might exist, but their value must not maybe not equal to each other. So double integral will not exist always.
yes, you are correct. It is false.
Yes,
So
sir.
there may be different kind of functions where f is not integrable, right? So it is very easy question. So
Yes, sir.
maybe, yeah. Okay, now I just like to recapitulate certain questions which some students gave me. So this is also very easy question. It has been taught by me. You see, this is the region of integration D, where region of integration is a rectangular region. It is bounded by 0, 0, 2, 0, 1, 2, 1, right? So this is the picture. And if we see that X is varying from 0 to 2. From here to here, if we go, then it is 0 to 2, right? So Y is varying from this line to this line in this direction. So at this point, whatever the arbitrary point, X comma 0. So what is Y? Y is 0. So 0 will be the limit for Y. And then what is Y here? Because we have to find the equation of this straight line. Y equal to what? X by 2. That means X equal to 2Y. That is the equation. So whatever the limit for Y here, upper limit, that will be X by 2. So this is dy first because you have to integrate with respect to Y first and then X is 0 to 2. So similarly, this is a type 2 region. We can go in the other direction also. So what is the limit for Y? You know, this is up to this. This is 1. So this part is 1. So Y is running from 0 to 1, right? And X is running from here to in this direction. What is X here? That is twice Y. Twice Y is here. And what is X here? It is 2 because this is the line is X equal to 2. Okay. So X equal to 2 and lower limit is twice Y. So twice Y to 2. And it will be dx because we have to integrate with respect to X first and then Y. And another question was that how it come 4 by 15. So this is just very easy because if you integrate it, then it is coming 4 by 15. I have checked it. That is why I have written it. You can check it. So I think you get the answer. And some questions regarding the existence theorem. Existence theorem, what it says? Ayan, can you tell? Or Rishi? Shubham?
Sir, existence theorem, I think it's Fibonacci theorem because it provides the existence, it provides us the information whether the definite integral will exist or not.
No, what it says? Existence theorem, whatever I have written in the lecture note.
Sir, if f is integrable, then and all the iterated integral are equal, then double integral will exist and is equal to the iterated integral.
No, existence theorem says that if a function is bounded on B, f is bounded on B, right? B is the domain of definition and it is continuous except for how many?
So I think so. We have not done this theorem.
No,
Existence.
I have done. And it is continuous except for possibly discontinuous along a finite number of graphs of continuous functions. Okay, then it is integrable. See, ideal situation is that if f is continuous on your bounded domain, then it becomes integrable. That is most ideal situation. So, but if simply function is bounded on a region, domain of definition, and it may be discontinuous along a finite is important, finite number of graphs of continuous functions, then we can say that it is integrable. And some students ask that he's having some difficulties in understanding. So if you see in case of single integration, whatever the theorem, it says that suppose this is a to b. I just like to relate this thing. This is function if f is bounded on your AB, and it may be continuous except for, here I do not say finitely many, except for the set of discontinuity of measure 0. Okay, so that means where the function becomes discontinuous, that means it is having certain discontinuity. It is very negligible set. It has to be very small set. Its measure has to be 0. That is the theorem. So that is known as the Riemann-Leibniz theorem. So similar way we can hear in this case also, in case of your double integration also, we can think that if you see certain volume elements, maybe rectangular parallelepiped, this is very ideal situation. So, but if it happens to be, suppose we like to calculate the volume of this region particularly, and it is if there are certain discontinuity at the some graphs of continuous functions. Suppose here discontinuity arise. So whatever the volume element for that particular volume contribution, this is certainly 0. So volume contribution will be 0. So if you have finitely many of them, 0 volume contribution, then there is no issue. You can still have the, you can measure the volume. That is why it becomes integrable. But proof is little bit difficult. And I gave just the statement of the theorem. Okay. So there is still another question. It has been asked by one of the students that whether you can integrate the Gaussian integral minus infinity to infinity e to the power minus x square dx. Whatever I did for using double integration, very simple way. And one student asked that whether he or she can do like in this way, using basically gamma function. Yes, you can do, but you have to use one gamma function property. So that is itself, if you go for the integration using the definition of integration, then that is really it's a tedious one. Okay, so you can do that, but a very simple way, whatever you can do, you can use double integration. You can use the change of variable to find the your Gaussian integral, value of the Gaussian integral, and it has been done in the last class, right? So in this class, it has been done. Okay. So I hope that all of you can see it. This has been done. It is very easy. Okay. So today I will start cylindrical transformation. So cylindrical coordinate system, that is the new thing today I'm going to teach you. So the cylindrical coordinates, what is that? R comma theta comma z. So this is of a point x comma y comma z. It has been defined by x equal to r cos theta, y equal to r sin theta, and z is equal to z, right? So where r is greater or equal to 0 and theta is having the full rotation. So all of you understand why it is happening. So why its name is cylindrical, because it gives ultimately a cylinder of radius r equal to a. So if we look at the picture, so this is your z. Suppose this is the point P, x comma y comma z. So this will be basically your r. This is your r particularly, and this thing is theta, and this thing is your z, right? So we are representing representation of x comma y comma z as in terms of r comma theta comma z. So transformation is basically x equal to r cos theta and y equal to r sin theta. If we do the calculation, x square plus y square is going to be equal to r, and theta is having the full rotation, you understand? So this is basically a cylinder. It gives a
The R
cylinder.
square. Sir, it will be R square.
Yes, it is r square. So x square plus y square equal to r square. That means x square plus y square. So it is giving a circle, right, of radius r. And ultimately it gives you, since your theta is having the full rotation, means 0 to 360 degree. That means ultimately we are getting a cylinder. And whatever the equation of the cylinder, just r equal to, you can tell a here. Any positive constant you can tell. Okay, so whatever the volume element, if we like to calculate it, then can you tell what? Yes, I like to come to the volume element. If I like to draw the picture here. This is your X, this is your Y, this is your Z. This thing is equal to theta. And this is your R particularly. This is basically your projection here. Okay, so what is your this part r d theta, and this is your dr small okay. So ultimately whatever we can get r dr d theta. So this part is d theta. So this is your infinitesimal volume element, right? Its projection on the xy plane is this. Okay. So if we write in terms of triple integration, then what happens? What will happen? This is very simple. If your W is any region in space, means 3 dimension, then triple integration over W, function is f of x comma y comma z, dx dy dz. You can write in any order because it is triple integration. I am not writing in terms of iterated integral. So it will be over W star, whatever the region in the cylindrical coordinate system. So whatever it will be, x is equal to r cos theta, y equal to r sin theta, and z is equal to z. So, and what will be dx, dy, dz? It will be replaced by infinitesimal volume element, that is r dr d theta dz. Okay, so this r is coming. Why it is coming? I already described. Okay. So where W star is the corresponding region in r theta z space. Okay, so let us do some exercise so that we can have the feeling. But here I like to tell something, in which type of situation we like to use the cylindrical coordinate transformation, that we have to know. Where the integrand function, particularly integrand function, is having x square plus y square as common. That is one part. Another thing is the region of integration, it has to be some cylindrical region. In those cases, we are in a position to write or evaluate the given triple integration in terms of your cylindrical coordinate transformation. Okay, so I like to give 2 examples at least today. One is suppose we have to calculate this thing z square x square plus z square y square. You see here x square plus y square can be taken, can be written in this way. Z square can be taken as common. Where W is a set of all x comma y comma z, such that x square plus y square is less or equal to 1, and z is in between minus 1 to 1. So you understand it is a cylindrical region, and height is particularly minus 1 to 1, and radius is 1, right? Okay. So how we can convert it? What will be here in this case particularly? We like to use cylindrical using cylindrical transformation, what we will get? We will get it uh, 0, that is your W star. This will be R comma theta comma Z, such that R will be 0 to 1. Theta will be, theta is having full rotation. There is no issue here, because x square plus y square less or equal to 1. So it is having, it is a full circle. And Z is, there is no change in Z because Z is equal to Z. So it will be -1 to 1. Okay. So what kind of integration we are getting? So this is -1 to 1. We can write 0 to 2 pi and then 0 to 1. This is simply Z square. I can take Z square common. So it is x square plus y square will be R square. So now I have to be very serious regarding writing the order of the integration. So it has to be dr first, because r is from 0 to 1, and then d theta, then dz, right? So I hope all of you understand this. So this is going to be equal to -1 to 1, 0 to 2 pi. So z square is keeping it intact. This is r cube by 3, and 0 to 1 is r. So d theta dz, here 0 to 1 r is particularly. So ultimately it will be -1 to 1, 0 to 2 pi. So it is 1 by 3 only. So z square by 3 d theta dz. So what it will be? I just give one step jump. Theta is 2 pi, so 2 pi will be coming here, and it is z cube by 3. So 1 by 9 is coming here, and z cube -1 to 1, z cube -1 to 1. So it is basically
4 pi by 9.
Sir,
okay. I have done a mistake here. Yes, it will be r dr d theta. R is coming.
Yes.
Yes. So I did a mistake here. So it will be r cube, means r to the power 4 by 4, right? So it will be 4, 2 pi, 4 into 3. So again here 2 will be coming. So 2, 4 pi by 3 will be the answer, right? So these are, we have to take into account. So I just erase it. This will be r to the power 4 by 4 it is. Okay, so all of you understand this will be ultimately pi by 3, because the volume element is basically r dr d theta. You see, this thing is coming, r is coming. Okay. Okay, next example I like to this is little bit difficult example I like to make here. A solid E lies within the cylinder x square plus y square equal to 1 below the plane z is equal to 4 and above the paraboloid z is equal to 1 minus x square minus y square. The density, this is one of the application point of view. I will be telling that how we can find it. The density at any point is proportional to its distance from the axis of the cylinder. We have to find the mass of particularly E, that solid. Okay, so we have to find the mass of E. So what happens here, if we try to draw the picture, say for example, this is 0, 0, 1. So it will be like this thing. So it is like this. This part particularly, z is equal to 1 minus r square. 1 minus x square minus y square, that means ultimately it will be z equal to 1 minus r square. And this thing is basically z is equal to 4. And this particular point, it will be 0, 0, 4. Okay. And this part is 1, 0, 0. And this thing is 0, 0, 1. All of you understand? 0, 0, 1. In cylindrical system, whatever we can write. So what is your E? This is R, theta, Z. 0 less or equal to theta less or equal to twice pi. And 0 less or equal to R less or equal to 1. And whatever your Z square, Z is upper height is 4. And lower height is this thing, you know, Z is equal to 1 minus R square. So 1 minus R square, so there is a change here. This is not constant, it is varying because it is a paraboloid. Okay. Now, whatever it is given, since the density at x comma y comma z is proportional to the distance from the z axis. So density function, show the density function, it will be a functions of x comma y comma z. It is basically k into square root of x square. This is the distance from the x axis, so k is some constant, so that means it is kr. K is positive constant. Okay, proportionality constant, but that is not known what is basically your constant. So your mass will be depending on the constant. So mass of E can be found by means of the triple integration. E k into square root of x square plus y square dv. Okay. So this is going to be equal to 0 to 2 pi. Then 0 to 1, I can write then 1 minus r square to 4 kr. This is kr. This part is k into r. Into r, what is dz first? Then dr, r0 to 1, then d theta. So all of you do the calculation. So it will be, I have calculated it, 12 pi k divided by 5. So you have to do it. Do at your own. Okay, so another home exercise I like to give you. Suppose we have to evaluate -2 to 2 minus square root of 4 minus x squared to 4 minus x square square root of x square plus y square to 2. Integrand is x square plus y square only. This is easy. This is dz, z is varying. This is dy, then dx. Okay, so we have to do that. We can use the simple integration to calculate it without using change of variable. But still, if we use cylindrical transformation, we get what we get. E star, suppose this is your E, this part is your E. So what will be E star in cylindrical coordinate? It is r comma theta comma z. So I think all of you, so where theta will be 0 less or equal to theta less or equal to 2 pi, it is having full rotation. R is up to 2 and z is in between. This is maximum is 2, minimum is z equal to r.
Root 2.
You know, this is r because x square plus y square equal to r square. So square root is r. So r is the minimum limit for z. Okay, so what it will be ultimately it is coming. Okay, I try to write it. So this thing is coming as 0 to 2 pi in terms of cylindrical coordinate 0 to 2 and r to 2. This is r square because x square plus y square equal to r square and r, and this is dz. This is dr. R is 0 to 2 and theta is 0 to 2 pi. Okay, so ultimately r cube dz dr d theta. So what it will happen? It is again 16 pi by 5. So you can check it. Okay. In the next class, because after coming week, so next class after your class assessment week means coming week from 10th to 15 possibly. So this is the week for your class CA1. Okay. So in CA1, I think you want to attend the classes. Okay. Let me allow the mic. I request you one
No,
by
sir.
one.
No, sir.
No.
No, sir.
Okay. Okay.
Order of
Sir, how R belongs to 0?
No, sir.
Yeah, how
Sir, I have a
R
doubt,
is
sir.
to
How R
have a
belongs
doubt.
to 0 to 2?
in the last question, that this question, how you write R said terms of R theta Z.
Sir, how R belongs to 0 to 2?
Okay. So you know, Z is equal to 2. That is the upper limit for Z. So whatever the picture. So this part is basically Z is equal to square root of x square plus y square. This thing, and this thing is basically Z is equal to 2. This is the maximum, Z equal to 2, and minimum is Z equal to x square plus y square. So this part is there. So you know this thing, if you draw the projection, so it is 2, here it is 2. Means 0, 2, 0. Here it is, this is your y-axis, this is your x-axis, this is your z-axis. Okay, so if you see this, then you realize that z is running from r to 2. Sorry, z is a square root of x square plus y square to 2. Okay. Okay.
Excuse me, sir. Excuse me, sir.
sir, how R is from 0 to 2.
Side 1E.
R cannot be,
Hello, sir. Hello, sir.
From 0 to 2,
R
sir.
cannot be negative. You know r is, r square is x square plus y square in this transformation.
Sir.
So r cannot be negative. R is starting from 0. This 2, the maximum is 2. Z is 2. You have to understand from the given integral. So this is your given integration. You have to understand that Z is maximum. Z is equal to 2.
Hello, sir. Sir.
Hello, sir.
Diagram of the previous question. Yes, sir. How you draw the diagram?
Sir, in assignment.
In assignment, what happens?
Yes, sir. In assignment, sir, question number 1E. Hello.
Hello, sir. Sir,
Yes.
I am having a problem regarding Moodle registration.
Okay, so class is not finished. Please wait for 1 or 2 minutes. After that, I will tell you.
Okay, sir.
Okay, so whatever I like to tell that after CA1 week, I will be starting your another integration, another coordinate system, that is spherical coordinate system.
Sir, is this triple integration also included in our CM1 test?
Spherical coordinate system, this I will discuss in the next class. I already told you that triple integration, whatever it will be taught up to today's lecture, it is included in your syllabus. So same question, redundant question, why you ask? So I think this is up to today.